All right, let's really get into it. We're going to explore what actually happens behind the scenes when you upload or watch a video on YouTube. You know, we click these buttons every single day, but the engineering that makes it all seem so simple, well, it's honestly mind-boggling.
So get this, every single minute, YouTube is processing 500 hours of new video. That's not a typo, 500 hours per minute. That's 30,000 hours of content uploaded every single hour. Just trying to wrap your head around that scale it's almost impossible.
And that really is the billion-dollar question, isn't it? How does a system like that not just collapse under its own weight? Well, to figure it out, we're going to follow the journey of just one single video, from the second you hit upload to the moment it plays on a screen halfway across the globe. This is how we'll see the incredible engineering that makes it all possible.
Okay, so our journey starts right at the beginning, the upload. And right out of the gate, we hit a huge problem. How does the system even begin to handle these gigantic files from millions of us all at the same time?
I mean, think about it for a second. A single, pretty short 4K video can be 30 gigabytes. You can't just handle that like you're attaching a file to an email. No way. You need a completely different approach.
Now, this is where we see the first really brilliant shortcut YouTube uses. The slow way, which you see on the left, would be to send that massive file through YouTube's main brain, its API server. That would just clog everything up instantly. So instead, YouTube does something way smarter. It has you send your video directly to its storage, completely bypassing that main traffic hub.
And the way they do this is with something called a pre-signed URL. The best way to think of it is like a temporary, single-use key to a secure locker. The main server just hands you the key, and then you go and put your file directly in the locker yourself. The server doesn't have to do any of the heavy lifting. So the whole process is this simple, incredibly efficient dance. First, your computer pings the main server and asks for permission. Then the server generates that special, secure link and sends it back to you. And finally, your computer uses that link to upload the huge file straight to storage. This keeps the main servers free to do all their other important jobs.
And here's another super clever trick. That giant 30 gigabyte file, it doesn't get uploaded as one solid block. Nope, it's broken up into all these small chunks that get uploaded at the same time. This makes the whole process way faster, and it's the secret to why, if your internet connection drops, your upload can just pick up right where it left off.
All right, let's move on to the next stage. Your raw file is in the system, but believe me, it is nowhere near ready for prime time. Now we have to see how this one uploaded file gets prepared for millions and millions of viewers.
And here's the fundamental challenge for this whole processing step. That one beautiful 4K file you uploaded has to play perfectly on a brand new smart TV with a crazy fast fiber connection, but it also has to play on a 10-year-old phone that's struggling with a 3G signal. One size definitely does not fit all. To solve this massive problem efficiently, the entire workflow is modeled as what's called a directed acyclic graph, or a DAG. Now, I know that sounds really complicated, but just think of it as a super smart to-do list for the whole system. It's what lets it manage and run hundreds of different tasks all at once without getting confused.
So the very first thing this smart to-do list does is split your original file into its core pieces. The video stream goes one way, the audio track goes another way, and all the information like the title and description, the metadata, that goes a third way. Now they can all be worked on independently at the same time. And this is where the real magic happens. Each of those streams fans out across a huge farm of computers. So while one machine is working on a piece of the video to create a 1080p version, another is working on a different piece for a 720p version, and a third is just handling the audio. It is mass parallel processing on an epic scale.
So the most important point to take away from this is that your one upload actually becomes something like 15 to 20 different files. As you can see in a table like this, it gets converted into a bunch of different resolutions, from 4K all the way down to 240p, and also into different compression formats or codecs. This is what guarantees that your video will be compatible with basically every device and network speed out there.
Okay, so the video is now prepped and ready in all its different versions. But how does it actually get from YouTube's servers to your screen smoothly, without all that annoying buffering?
We've all seen this, right? You're watching a super sharp, crystal clear video, and then, for just a second, it gets a little blurry, and then it snaps right back into focus. Well, that's not a bug. It's actually a really clever and absolutely essential feature at work. It's called adaptive bitrate streaming. Basically, your video player is constantly talking to the network, monitoring your internet speed in real time. If it sees your connection is great, it asks for the high-quality 1080p stream. But if your Wi-Fi suddenly gets weak,
it seamlessly switches down to a lower quality 480p stream to make sure the video never stops playing.
And here's how it pulls that off. Instead of trying to download one giant video file, your phone or computer downloads tiny little chunks of the video, just a few seconds long at a time. And before it grabs the next chunk, it makes a split-second decision about which quality version to get based on what your connection looks like right now.
Now, to make this whole thing even faster, YouTube doesn't serve all its videos from some central place in California. It uses what are called Content Delivery Networks, or CDNs. These are basically servers placed all over the globe. Copies of popular videos get stored on these local servers, so if you're in Tokyo, you get the video from a server in Tokyo, which dramatically cuts down on lag.
So now that we followed that entire journey, let's just step back and pull it all together. What are the core ideas, the fundamental principles that let this system work at such an unbelievable scale?
It really all boils down to these 3 brilliant engineering principles. Number 1, use direct uploads to keep your main servers from getting bogged down. Number 2, use parallel processing to turn a slow, one-by-one task into a massive, do-it-all-at-once workflow. And number 3, use adaptive streaming and local servers to guarantee a smooth playback for absolutely everyone.
And what's truly amazing is that these ideas are not just for YouTube. Once you understand them, you start seeing them everywhere. Services like Dropbox, complex machine learning systems, even live video streaming. They're all built on these same fundamental building blocks of the modern internet.
And that leaves us with one final provocative thought. The incredible technology we just talked about was built for the challenges of today. But as video files get even bigger with 8K, and as immersive VR experiences become the norm, the innovation can't stop. The next great engineering challenge is already on the horizon.